I'm not going to. Okay, so the biggest part to remember and the most that people mess up that I can remember is so x minus h squared plus y minus k squared equals radius squared. So speaking to misconceptions and where most of the mistakes happen, getting our x and y's confused, forgetting that hk is your center. So hk is always the center. And then h is your x value and k is your y value. And then the radius squared. This part rocks everyone's world. So you take your radius and times it by itself twice or raise it to the second power. Now, if they give you a question with a diameter, this is so silly, but diameter is 2 times your radius, not radius squared. Be careful because a lot of times they'll have a question, or I've seen it in lots of the reviews for EOCs and tests for this unit from other teachers in other places. They give you the equation and then they ask you for the diameter. And if I ask you and sit in front of you and say, what is the radius? You can tell me the radius. And then I say, okay, if the radius is 5, what is the diameter? Without context, you tell me 10. Something about writing this equation and discussing circles and squaring radiuses, and your brain gets on this roll, and then you'll tell me it's 25. So just make sure you remind yourself, diameter is 2 times radius, not radius squared. And I say that again because you might be rolling your eyes thinking that's like, oh, well, duh. Too many times do very smart students just make that hiccup. And that's a silly hiccup relative to the amount of hard math you have to do. So those are some of my call outs as far as like misconceptions. Also, fun fact, this is the distance formula. The square root equals distance, but they took the square root off of this side off and put the square on this side. So it's basically your square root formula before the very last step if you're using Pythagorean theorem to compare. So very similar to a formula you've learned before, just whether or not you can see the correlation and how well you memorize that one in Math 2 is when I think you used it the most. All right, given a circle with a center. My humble opinion, I would, as soon as I read that, write H and then write K. And if it's on the computer, obviously like our EOC, I would write it down in the corner of my paper, coordinate 3, -4, and I would label it HK. Passing through 6, 2, so that's going to be your X and your Y. And those labels seem like a silly step, but again, not a hard concept in the midst of your EOC with 60 questions, sitting there for 4 hours in a classroom you never hang out with, a bunch of people you don't know. You are going to get distracted. And then probably off in La La Land just because it's a lot of time. So those small kind of skills are very helpful to EOC success. So then we're going to take our X and our H, and we're going to subtract them and square them. And then we're going to take our Y and our K, and we're going to subtract those. And in this case, we don't have our radius. So we have to solve for our radius. We have our center, and we have a point on the circle, so we don't know the length of the radius. So 6 minus 3 is going to give us 3. And I may be overriding because some of you are going to be able to do this math in your head. So minus a negative is going to turn this into a plus. So it's going to be 6 squared equals radius squared. 3 squared is going to be 9 plus 36 equals radius squared. And this is going to give us 45 equals radius squared. Now, fun fact when you get here. This is where I would stop and I would go back and figure out what it is the question's asking. In this case, we are trying to write the equation, so you can stop. If it does ask you what is the length of the radius, what is the length of the diameter, then you're not done. Then you would need to know that the radius is the square root of 45. And that may be then written as a decimal. It may be written as a simplified radical. It could be written in lots of ways. If you have a calculator, use it. Change the answer choices to the kind of answer that makes sense to you, because you can plug this in your calculator and turn it into a decimal. If they have it simplified, you can plug their messy, mixed up one and compare it to the square root of 45 and make sure your decimals are the same. But in writing the equation, you are then going to use your center, which is our 3, And in this case, that -4 is our k, so we're going to make +4 squared equals radius squared, which is going to give us 45. I often, when I finish, before I write the equation, I go back and I'm like, okay, this is center, this is radius squared, because that's another misconception. There's just a lot of numbers on your piece of paper by the time you get to your final answer, and going and grabbing the point it passes through is another oops. That when I've called students on, like, hey, why'd you use this point? When they read it again, they say, oh man, that's not the center. And it makes sense to them where their mistake was. But again, a silly oops. And the reason you have to use the center is because a circle is a ton of points that go around at the same distance, which is all the x, y's that make up the circle. So you could easily give you a coordinate and say, does this fall on the circle? As they've done in linear functions, exponential functions, and all the other fun things. And that would plug into your x, y, solve it, and does it indeed give you that radius squared? Would be another way for them to ask kind of silly questions on the EOC. As I've said, Math 3 EOC doesn't spin questions up quite as much as like Math 1. Math 1, you had easier content, strangely written questions. This is pretty much newer content, so it's kind of, I would say, maybe equivalent to like your 8th grade test if you got to take an 8th grade test. It's just you need to know what it's asking for and not get distracted in the midst of it. So again, a center and a point. So you're going to do the same thing. So you need to identify your H, your K. He's the most important when you're done. That's the guy you're going to come back to. Your X and your Y. What are you missing? You're missing that radius. That's what you need to solve for. Or radius squared, again, if the question is just to write the equation of the line. I'm going to skip that one because I believe we're okay. Maybe just conversationally, I'm wanting to give you some heads up against for some misconceptions on EOC day and test day or quiz days. Given a circle with a center at the origin, in any other context, you can tell me where the origin is. It's the point in the center on the graph. For whatever reason, we have people get a little shaky when it's not given as a coordinate numbers in the problem in this context. So origin is 0, 0. Write it as a coordinate. Passing through a point. So again, we are missing our radius. So you want to identify H and K as your center. And then your X and your Y of the coordinate that falls on the outside. Solve for radius, and then we're going to plug back in. And again, in this case, we're writing the equation of the circle. So radius squared, you can probably stop there and just use it in the equation, not having to take the square root. Again, a reminder after class this morning, the square root is the inverse operation of squaring. On your TI-84s, it is the same button. And then obviously you have Desmos for your entire quiz or your entire EOC. I can't say that enough. I've had more students tell me they didn't realize the calculator was there. Then makes my heart happy. You do have a calculator embedded in your EOC, and it is exactly the Desmos we've been dealing with all semester. Please use it. Please use it. From previous classes, so endpoints of the diameter. I'm not really sure why this blows everyone's mind because there's only one added step. The two things you need to write the equation of the circle is your center, which is your HK, and then you need your radius. And then we're going to actually use it as radius squared. Those are the two things you need to write the equation of a circle and be done with it. If I'm given the circle with 5, 1, and 3, -1 as the endpoints of the diameter, that means I have neither of those things. But I do know that the diameter is 2 times the radius, and I can find the center by finding the midpoint of the diameter. So you could go about this a couple of different ways. If you are visual and you want a graph, you are allowed as much graph paper and blank paper. And again, you have access to Desmos. That is one way as well to get through this style problem when you're given the diameter. So just find your origin. So I have 5, 1. Go 5, 1. Sorry. 3, -1. So this is the diameter of the circle. So ultimately, without being perfect, our circle would go around that guy. And we need to know what the radius is this way. Hopefully you see at that point, if you remember distance formula or even slope, rise over run is 1 to 1. This is my right triangle. So our radius is definitely not 1. But my midpoint is on here at 4, 0. So now you have your HK. It's the middle of that line. Otherwise, you would do it algebraically. And we would need our midpoint, which means we're going to do 5, 1, 3, -1. And midpoint is x plus x divided by 2, y plus y divided by 2. Or I like to stack them, add them, divide by 2, because you're not dealing with endpoints at all. So that was the little thing that I memorized from way back in the day to make it easier. So stack them, add them, divide by 2. And that would be beneficial if you mix up your x's and y's every now and again. Like you get excited and you just use a whole coordinate and divide by 2 whole coordinate. So our x and our x would be 5 plus 3 divided by 2. And then 1 plus a -1 divided by 2 is our y. This is 8 divided by 2. And this is going to be 0 divided by 2, which is that 4, 0, which we also found on our graph. So 4, 0 would be on our graph. Again, now you can either, if you wanted to use your graph and look at this right triangle, it's a 1 to 1. So that's where you would do Pythagorean theorem, 1 squared plus 1 squared equals c squared. For the hypotenuse of this right triangle, that would give you the length of your radius. So that's 1 plus 1 equals c squared. 2 equals c squared, which in this case is radius squared. If you're doing distance, it would be the square root of 2 equals c. Or in this case, your radius. And if I square the square root of 2, I get 2. So that's just another way to go about it. But if the previous problems are fairly easy for you, continue to do so, because now I have my HK and I have 2 coordinates and I can pick whichever I want to use. So if my H is 4, my K is 0, I'm going to pick the smaller one, so 3, -1. X is 3, Y is -1. So X minus H squared plus -1 minus K squared equals radius squared. 3 minus 4 and -1. -1 minus 0 is -1 equals r squared. I don't know if you see the pattern here. Now this looks exactly like Pythagorean theorem like we just did. And that's going to be -1 squared. Call out if you grab your TI-84, because you will have it on test date, so I've been told. If you don't use parentheses, this will tell you that the answer is -1. So if you type in -1 squared in your calculator with no parentheses, and sadly, on the days that we do that, most of us believe it because you think the calculator is never going to lie to you. Fun story, it definitely does. And it's not even that it's lying. It doesn't speak student. If I put it in parentheses, because we know by this point that a negative times a negative is a positive, then it squares the entire -1 instead of squaring the 1, attaching the negative. So it's just a miscommunication, but be careful. So -1 squared, 1 plus 1 equals r squared. 2 equals r squared. So our radius squared is 2. Again, the same as we just solved on our other paper. The important parts to write that equation are going to be our HK and our radius squared. And so we're going to write the equation as x minus 4 squared plus y minus 0 is never how you're going to see it. So you're just going to see y squared equals radius squared, which is 2. So if you saw this, they could ask things like, what's the center? What's the radius? What's the diameter? In this case, the diameter is not 2. It's not 4, because the diameter would be the square root of 2 times 2. So 2 times the square root of 2 would be your diameter, because it's double the radius. And the actual radius is whatever decimal the square root of 2 is. So we'll do another one of those. Do you have a preference between the graphing versus the algebraic? Do you guys? Okay, I think the graphing is easier too. Just making sure though. Okay, so given a circle. Okay, all right, perfect. Well, then I will do both. So we'll graph these points. So 2, 1. This is the diameter. And we're going to go 6. So 2, 3, 4, 5, 6. 1, 2, -3. And that means this is the diameter. The midpoint of that line is going to be the center of the circle. So you can count it up 4 over 4. So half that. So it's a 4 over 4 length line. And that being that I counted 1, 2, 3, 4. 1, 2, 3, 4. And if I half it, that's 2 over 2. So up 2 over 2. Up 2 over 2. This segment is now congruent to this segment. So now we have our center, which is 1, 2, 3, 4, -1. You could find the length of your radius, because this is our radius, and that's a 2 by 2 right triangle. We can solve for radius. And that's a squared plus b squared equals, we'll say r squared, but c squared if you're thinking Pythagorean theorem. Radius squared, since we're turning this into a circle, hopefully. 4 plus 4 equals r squared. 16 equals r squared. Now, you need r squared to write the equation, but if we want to know the length of the radius... Oh, I did that completely wrong. 8. Phew, what was I say? That is really big. So square root 8. 4 plus 4 is 8. Silly mistake, sorry. So our radius is going to be the square root of 8, or a decimal to whatever decimal points that the instructions tell you. Simplifying this guy, you may see it. Square root of 2, square root of 4 is also the square root of 8. The square root of 4 is a perfect 2. So you may see it as 2 times the square root of 2, because that's the cleaned up version for radius. Don't panic, that's weird. But all you actually need is this guy and this guy to write your equation, center and radius. Again, this is not the way you have to do it. It's just an extra, like, again, if you're better visually graphing and seeing it. Algebraically, diameter, we need the midpoint. So 2, so x and x plus 6 divided by 2. And then y plus y. 1 plus a -3 divided by 2. That's going to get us our midpoint. So that's 8 divided by 2, which is going to be 4. And then 1 plus a -3. I owed you $3 and I handed you $1 means I owe you 2. So -2 divided by 2 is going to be a -1, which is exactly what we found on our graph when we counted it. So this is our midpoint, or the center of the circle. Sorry, I was doing midpoint and distance in Math 1 this morning, so my words might be mixed up between the two. So now I have a coordinate, so this will be our HK. Pick whichever one. I'm going to do 2, 1 because those are tinier numbers. So I'm going to do x minus h squared, y minus k squared equals radius squared. And I did minus minus just so you know where they came from, because that was a negative and the formula is a minus. Remember, minus minus turns into a plus. So 2 minus 4, -2 squared. 2 squared equals r squared. Again, that looks exactly like Pythagorean theorem that we did here. So we've just replicated without, just in a different pathway. We got there. So -2 squared is going to give us 4 plus 4 equals r squared. 8 equals r squared. Again, all we need is r squared to write the equation, though the radius is the square root of 8. So we write our equation x, find our h minus 4, so back to our center, squared plus y minus k, that's a -1. They won't write minus minus, so let's put plus 1 squared equals our radius squared, which we just solved and got the positive 8. All right, these are the ones that I'm pretty sure you are definitely going to see. There is a released EOC question of this style question. I just realized we've hit time, so I will hold off until Monday for these.